I belong to a company that is devoted to the implementation of BIM in global companies. Today, we will try to outline some of the problems of companies that do not implement, why they don't implement, and those that do implement because they do implement, and those who have implemented, why they've had problems from what we have observed. But we don't want to boast or be falsely modest. That pathway is called boredom. So we will try to skip over those things and go straight to two concepts. A concept that I found here just a few days ago, a very Catalan concept, a very interesting concept, and I hope that some of you will help me, that of sane and Rauscha, news and chaos. This sane is the common sense, systematic, rational thought, and Rauscha is the chaos, the flow, the yin and yang, as Luis was telling me. But that has much to do with the history of Catalonia and how the Catalan community has progressed throughout history and has much to do with the implementation of these new things. Another concept is one that I'm very interested in and I'd like to bring to this discussion. We use it a great deal in Buenos Aires, where we hold many courses, training, distance training, and so forth. It's something that Fermi introduced, a friend, a mathematician, who, throughout history, incorporated this very interesting concept. How many piano tuners are there in Chicago? And we ask a number of people like you. Just write down on a piece of paper how many piano tuners there are in Chicago. And in the next 5 seconds, we will get an average, a standard deviation. That could be the average of anything. It could be 5,000, 50,000. It could be any number. But now, as we advance with the concept, how many people live in Chicago? We don't know. Buenos Aires has 10 million, so there may be 7 million in Chicago. What about the Chicago nuclear family? Is it 2.5 kids per family, a mother and a father? If we divide the total population by those numbers, we'll get the number of families. How many people have a piano? Well, I have no idea. But I have 20 friends, and 2 of them have pianos. So maybe 10% and 15% because Chicago is the birthplace of jazz, so that would give us a number of pianos. Then we asked, and how much does it cost to have your piano tuned? I don't know, $100? No, but not 1,000 either, so maybe 300. So 3,000 multiplied by the pianos gives us the turnover. And how much do they make, these piano tuners? They probably couldn't live on less than 4,000 or 5,000 per month. And so take a piece of paper, and again, we take the average and the standard deviation, and we realize that that average does coincide with the number that we have at the Piano Tuners Association of Chicago. No one knows Chicago, and the standard deviation was very small. So with a very complicated problem, we break it down into simple problems and reach the solution. So throughout my presentation, we'll be introducing this idea. Where do we find sin, the common sense? Where do we find Rauscha? And where are these piano tuners in Chicago? This person began to divide the entire BIM concept into 3 areas. The first part, the architectural studio, where the project is developed. The second area that they call BAM, it's called BIM Bam Boom. But BAM has to do with assembly, with construction, and boom, one of the O's is the O of operation. And this person asks, for each dollar or euro invested in BIM, 20 cents are invested in assembly and 70 are invested in maintenance. This is going to accompany us throughout the entire presentation. The first 2 numbers are very easy to find. One is 5% of the construction cost. So more or less, talking about reasonable ranges, 5% is what is invested in the project. But the interesting thing that the interesting conclusion that this man reached is that throughout the service life, they spend 3 times the amount of the construction cost on a building. So BIM is going to accompany us throughout the entire service life, and we begin to reach some conclusions. Again, going back to these piano tuners, to break down this problem and to break it down into simple problems. And if this BIM is going to accompany us from the initial stage to the end, what characteristics should this BIM have? One of the characteristics is anything that we do, any genetic problem that we have in the BIM stage is not going to accompany us in the BAM or the boom. If we have a column that has the same diameter in 7 stories of the building, and in our BIM phase we have it as a single element, we'll never be able to have the calculation of concrete per floor or have a certification per floor. The same thing will happen if we have a concrete slab with multi-layers above it, and if we add these multiple layers, we won't be able to certify in BAM this concrete because we will be advancing by floors and we'll only have the concrete part, and that won't give us the complete number. When we get to the BAM, it's easier to redo it than to fix it. And what is the solution? To tell these people that I don't want a BIM. I want you to do it this way, to not have to redo what you've already done. This is a protocol that we need. And it's not one single protocol for all disciplines or all the types of works. But the other important thing to remember is that in order for us to tell architects, builders, and maintenance people, the facility management, who use BIM, it has to be good for them. They're not going to make a sacrifice just for the sake of sacrifice for us. Is it profitable for each of these stages? And I would say undeniably yes. In architecture, we all know that there is a BIM model and all of these plans that are monitoring the BIM products. If I move a column over here, it impacts all the other plans, and that is much cheaper than going to each of the plans and moving the column and forgetting one of the plans or the drawings, and it ended up being a pedestal. Another thing is to installing doors here and there. We're sick and tired of redoing these activities hundreds of thousands of times. As many doors as there are in a project, it's simply cheaper to do it in BIM. In BAM, it's also cheaper. Finding a clash or an interference between 2 installations when we're on the work site costs from $300 to $500, but finding it inside a model costs $30, a tenth of the cost. So how to justify this? Give me a 10 euro bill and I'll give you a 100 euro bill. Did you like that? When you want to multiply that transaction, we'll keep talking about this topic. You can keep the 100 euro bill. It's very important to give somebody 100 euro in the bill, not just for, maybe not for you, but for the other person. It is important. But that makes it very clear the position of this concept. And obviously in the boom stage, it's also very important because we handle 3 times the cost of the construction. Everyone knows that preventive and predictive maintenance is much cheaper than any other form of maintenance. So who must decide all these things? If it's economically profitable, who has to decide on this? It cannot be decided by a single technician. Imposing an administration accounting system on a company, you don't ask the secretary if you can do that. If you ask the secretary if you can implement, if it's easier for her to draw up a bill by hand or with a system, she'd say it's easier by hand. But if someone who really understands the problem goes and says, listen, I don't mind if you take longer to do this. I need to press a button and have the company's balance sheet appear. So we can't leave it in the hands of an architecture studio to see who decides. It's the owner who has to go down and make the decision and make it clear. But not just any BIM. It has to be this BIM. And that owner has to give the technical specifications of the BIM. And who is going to do that? The owners have the money, but they don't have the knowledge. The person who helps them is the project manager. The project manager is the person who advocates the interests of the commissioner, and they are the ones who must make it very clear what has to be specified, what has to be stipulated, and that the BIM to the boom is a very clear path and you don't have to redo any work. But above all, the BIM must be done completely. In the BIM, the BAM, or the boom phase, or you have to do it 3 times, it doesn't matter. It's more than likely economically profitable. If this is the case, why is it not implemented? Because there's fear. Generally, problems are human, not technical. The fact that there is economic viability does move a certain willingness. And an ounce of convenience is equal to a pound of willingness. People do it because it's convenient. But others think that it's no good, so they do it all in CAD and they convert it into BIM. Or they say, yes, I did have to do the job twice, but that should not be the case. But implementation, is there anyone here who is responsible for the technical department, but with a management background? If there is, they'll understand what I'm talking about. Delaying implementation is the most mortal subspecies of no. It's a no disguised as yes. They say, yes, it's great, it's profitable, but you keep delaying it, so you don't generate any antibodies. Because if you say no, it's too expensive, or no, because it's too difficult, or then we can debate it. But delaying it, be very careful with these delays, because this is a problem. What is the difference between an expression of desire and an objective? A plan. That is what turns an expression of desire into reality. I want to play the lottery. I want to win the lottery. Do you play the lottery? No. So then, many people want to have the feeling that they're involved in BIM because they've been thinking about it for a long time. Listen up. If you hit like on Facebook, on Greenpeace's Facebook page, you're not helping the whales. The only way to help the whales is to really go out and do something for the whales. So just thinking about BIM for a long time. I've been thinking about this for 30 years. And I say, yes, I've been trying to lose weight for 20 years and I haven't lost any yet. And that's what we're saying. It's not an opinion. It's not that we analyzed it and reached this intellectual conclusion. It is a conclusion that follows many years of being partners, having over 3,800 students in a virtual classroom at once, helping 250 companies going from CAD to BIM, doing over 1 million square meters per year. It's 1.4 up here, but it's over 1 million square meters per year in BIM documentation. And then realizing that it wasn't just a matter of training people. We also had to teach them, implement, and support all these methodologies to make it a reality. And our job was to coordinate people, processes, and tools. This is another area. When we come to a company, we can write up a procedure handbook, but that's not it. We have to coordinate the people that they have with the computers that they have in the processes they have, and then decide what tools are most suitable. And we have done this not just for the 4 stakeholders in the BIM Bam Boom, designers, builders, and manufacturers, and end users who are the ones who use the building, but also for owners. The owner, the person who commissioned all of these things and asked all these people to do these things. So let's have a look now at some examples. We have examples of BIM, examples of BAM, and examples of BOOM. This is a shopping mall in Ecuador, 250,000 square meters. The architecture studio decided to do it because they understood that it was in their best interest. This is a chemical laboratory where an architectural firm found a significant problem for this laboratory to put in 1.8 meters of ceiling 18 different installations. This could not be done in a different way. And so that's how they began, and they ended up implementing it for much simpler problems. It was like this was something for complex problems only. No, that's not true. It's for homes or even for furniture in my son's bedroom. I'm not going to do it in CAD. This is in the BAM phase now. A building company that the commissioner obliged to do BIM. They didn't want to do it, and now it's being built in Puerto Madero in Buenos Aires, 85,000 square meters of works. But they really got into it at such a level, and now they're implementing it for all their companies. The order came from the commissioner, and now they're implementing it on their own. In this process of implementation, some projects are done by us, and we design something of a plateau of work. They design their things internally, and we can cover the peaks, the peak demands. That's another matter. This is another building company in Uruguay with a wine cellar, a very large winery, and they decided to do all the documentation in CAD, and according to their contract, they didn't want to lose the money from the clashes, the 300 and 500 euros per clash. And so they said, well, we'll do BIM on our own because it's in our best interest. It's economically viable and profitable. And they, you say, I don't know if it was up to me or... No, I'm just doing it because it's economically in my best interest. This is the BBVA Bank in Peru. They had to change their corporate image at 80 offices. Can you do it in 1 year, 5 years? You can't do it in 20 years. So a project company hired us to design a methodology in order for them or someone else to generate all the documentation necessary and reach their goal. A few months later, HSBC in Mexico, the same project company. It wasn't directly from HSBC. It was part of the BAM phase, okay? And in BOOM, in facility management, in completed buildings, the National Bank of Buenos Aires, 10,000 square meters, the clinical hospital here, shopping malls, people who do BIM just for the facility management part. This is also true. So it's economically convenient in all these companies. This is facility management. It's just people's free will who are going to BIM because they know it's in their best interest. And following all of these examples, let me show you two more things. We find ourselves facing real problems, and we realized what those problems were. Those problems, we realized they weren't technical problems, but administrative problems. These administrative problems allowed us to divide up, like the Chicago piano tuners, the problems into simpler problems. This is just an example. We have a building with all of its floors on the horizontal axis, and on the vertical axis, the systems, architecture, structure, carpentry, and so forth, the sanitation installations, and so forth. And inside each one, we'll have BIM, the BIM for the architecture of the first floor, of the second floor, the third floor, and so forth. And we could also incorporate the CAD information that's inside. This is an administrator that ends up in folders because this manager, the BIM manager, which is the person who has to implement all these things, has to begin to administer all this information. Up to now, they've gone crazy. Where was the information? What was it called? What was the last version? And so now we'll see how it worked. This was a tool that helps do these things. Here, you can see how the information that we have in CAD on the project. Here we have air conditioning on the 6th floor. We click. It calls up the file, the CAD, and we have the available information without having to go look for it anywhere. Then, if we wanted to, we could go to Reddit. And again, air conditioning on the 6th floor. Click, and we see what the model looks like. So it's broken down. Our whole overall problem is broken down by systems and floors. What about the masters to coordinate in 2D? So for the 6th floor again, let's see some documentation that is prepared, that appears automatically when users fill out these BIM projects. We have all the documentation here in the design review without having to go search for it. This work allows us to work in depth so that when the information comes in and everything is ready for it to work. We can also look at vertical coordination now with a master that joins together all the verticals. We will see the system. I think it's the sewage system in this building with all of the necessary displays. Okay, there's also a 3D coordination, the 6th floor. Now we can look at all of the installations together to see any clashes and do some clash detection. And the project is very light. We don't need some incredibly high-powered computer. We have run-of-the-mill computers with 8 giga RAM and users who fill out the information without any trouble. And we also have the diagonal coordination of this matrix, the total model, which we see in Navis in this case. So, what are we really saying? That we break down this entire problem into simpler problems, and if in this matrix, in this table, I have 200 files, 200 BIM files, and I give 200 files I give you each one file, and I know it's going to take you 10 hours each. We're going to have the project finished in 10 hours. So it's very simple training. I say, listen, you have to include columns. You just do it like this. Column, column, column. Did you get it? No. Column, column, column. Did you get it? No. Column? Okay, I got it. Column, 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 column. Beam, 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 beam. Pipe, pipe, pipe. And then, in a very short time, with people who don't need in-depth training, thanks to there being a method behind it all, we can achieve incredible outcomes. A method makes it possible for an idiot to achieve at least a good outcome. If they're not an idiot, they'll have an even better outcome. But we don't need supercomputers. We don't need geniuses. But the hours that we also include in the system, the estimated hours, gives us an idea as to how to administer any deviations, which I won't go into too much detail on, but here we have some projects, and inside the projects we have some clients, we have clients, and inside the clients we have projects with the estimated hours, the real hours. It's all information that we need to certify, to see if we're on time, not on the work site, but in the generation of the BIM project. We know that there's a file on which there is 5 days worth of information to complete, and no one is doing that. So just to finish up now, 2 final invitations. The first is to implement, to perform the boldest experiment, to reason, to even crazy extremes, taking the soul out of the concepts with perplexity, generating in this process avant-garde intellectual expressions, that is the Catalan sen, the common sense, to develop the skill of implement and open new pathways for the spirit that will surprise us, amaze us, and understanding it as a joyful event. That is Rauscha, the chaotic creativity of the Catalan people. Keeping it all in a drawer is keeping an idea in a drawer is like platonic love. It's like hypocrisy. But if a physical action is not preceded by an idea, it is the self-deception of a fool, and that's expensive, and that's why people fail, because they start working before they start thinking. this balance between the sane, the common sense, and the Rauscha, the chaotic creativity. The last proposal that we have for you today is that you use us. We invite you to use our madness, to use our passion, to use our obsessions, and the square meters that we've done. Because our knowledge, you may be matched with us for our technical achievements, but we're completely mad, and no one can match us in our madness. BIM is going to have a huge impact over the next 4 to 5 years, one way or another. That decision to implement must be a conscientious, very much a sin, and very much a Rauscha decision. If you write us at this email, we'll be able to give you a lot of information. You could do so right now with the subject Bimbox. And if you want to add a query, I will personally resend that message to the person who has to respond directly to you. But we also have Javier Calvo, our Spanish representative and close personal friend, at your disposal. So I don't know whether to say thank you or excuse me, but I will say see you soon, because we're so crazy. We want to stay in touch with you, and I'm sure that you will hear much more about us in the future. Thank you.